Hello everyone. In today's video, I'm going to discuss acids. So let's begin. Acids are those compounds which produce H plus ions in water. That means when you put an acid in water, it will produce H plus ions. Now let's see what happens when you put an acid in water. Like you got HCl, and if you put HCl in water, what happens that it converts into its ions. That means it produces H plus ions plus Cl negative ions. Right now HCl is in aqueous form, while H plus will also be in the aqueous form and Cl is in the aqueous state. So this is known as ionization, or we can use the word dissociation. So we say that HCl, it has dissociated into its ions when you put it in water. Now let's see another example. For example, we've got nitric acid. If you put nitric acid in water, what will happen? That it will convert into H plus ions, along with you get NO3, and nitrate is NO3, one negative ion. So these are the aqueous ions. Next, let's see sulfuric acid, H2SO4. It converts into its ions to form H plus ions plus SO4. Now SO4 is a 2 negative ion. So there are two H over here in this equation. You got H2SO4. That means there are two hydrogens. So you write 2 here to balance this. So sulfuric acid, aqueous, it will produce 2 H plus ions and 1 sulfate ion. So in total, if one molecule of sulfuric acid is added to water, it will produce 3 ions, 2 H plus ions and 1 sulfate ions. So this is something about the ionization or dissociation of acids. Now let's see the properties of acids. Acids, they are sour in taste. You have tasted many acid, like you have tasted citric acid in the lemons. Uh, Similarly, we have many acids that we can eat, like we can have tartaric acid. There is present lactic acid. These are the acids, or many other, like we got malic acid as well. These are the acids that are present in our like different foods. So the next thing that we have to see, that acids, they are good conductor of electricity. But in which state they are conductor of electricity? They only conduct electricity in the aqueous form. That means when you put them in water. Okay. Otherwise, if they're in the solid state or if they're in the molten state, they don't conduct electricity. So acids conduct electricity only in the aqueous state, because in the aqueous state they are converted to their ions. That means they contain freely moving ions. Freely moving ions are present in the acids in the aqueous state, so they can conduct electricity in this form. Otherwise, in the solid state or in the molten state, they are non-conductors because they don't have any ions present in those states. So now let's see, we have to see the reactions of acids. Let's move ahead. So the first reaction of acid that we have to see is that the reaction with metals. So if you have metal plus acid, so when you put a metal in acid, we get a compound that is called a salt, along with the hydrogen gas is released. For example, we got magnesium metal, and if you add into an acid like HCl, what will happen? The magnesium metal, it will replace the hydrogen H plus ion from the solution, and what we'll get? We get the magnesium chloride. Now you should know that how to construct the formula of the salt over here. Look, magnesium Mg is a 2 plus ion, while Cl is a 1 negative ion. So when you construct the formula, this 2, it would come over here. So making this as MgCl2, along with we get hydrogen gas. And then we have to balance this equation. There is 1 Mg over here and 1 Mg, while there is 2 Cl's over here and we got only 1 Cl. So we have to write 2 here to balance this equation. Now hydrogen also gets 2 and there are 2. It's fine now. Let's see one more equation. For example, we got zinc reacting with, let's say, nitric acid. Now zinc will replace hydrogen and it will combine with nitrate, you can say, and H it will release out as hydrogen. Now let's see how to construct the formula of zinc with nitrate. So zinc is 2 plus ion and nitrate is NO3, 1 negative ion. So what happens here, that this 2 that will write over there. Now nitrate is a polyatomic ion. So how do we construct the formula of zinc nitrate? It will be zinc and we'll use a bracket over here and then nitrate NO3 and it's twice over here, along with the hydrogen gas is produced. So we get zinc nitrate plus hydrogen gas. Okay, what are the state symbols? Zinc is a metal and metals, they are in the solid state, while acid we take in the aqueous state. Zinc nitrate is a soluble salt, it will be in the aqueous, and hydrogen will be a gas. The similar state symbols we'll see in the above equation. A magnesium solid, it's aqueous again, and the gas. So this is the first reaction of metal with acids. We can take another example. For example, you have a metal like a sodium metal reacting with sulfuric acid. Sodium is a very reactive metal, so sodium will combine with the sulfate ion. So sodium is group 1, it is +1, and sulfate is SO4 2 minus. So we will write this 2 over here. So we get the formula sodium sulfate Na2SO4 plus hydrogen gas. So all these compounds, that is the magnesium chloride, that is the zinc nitrate or sodium sulfate, they are all salts, and along with we get hydrogen. In these reactions, what we will observe? So we will see actually the bubbles of the gas. Bubbles of H2 gas will be seen. You can call it as fizzing, and different metals, depending upon their reactivity, they will produce a different volume of gas in a given time. If you take a fixed time, for example, you take 1 minute, so you will see different metals, they will give you a different volume of gas produced. So this was the first reaction, that is metal react with acid to form salt and hydrogen. Let's see the next one. So the number 2 reaction of acids is with metal oxide. Metal oxide plus acid, they will give you a salt plus water. Metal oxides, they act as bases. For example, we have a metal oxide, for example, magnesium oxide. Oxide is 2 negative ion and Mg is a 2 plus ion. So you'll get MgO. Magnesium oxide is MgO. And let's take another acid, like you got sulfuric acid over here, H2SO4. So what we will get? The magnesium react with sulfate. Now how to construct the formula of this salt? So Mg is 2 plus, SO4 is 2 minus. So both of the charges are cancelled. The formula will be MgSO4, magnesium sulfate, along with H2O is formed. Remember, MgO is an oxide, and metal oxides, they are always solids, and sulfuric acid will be in the aqueous state. Magnesium sulfate is a soluble salt, aqueous, and water is in the liquid state. So let's see a next oxide. For example, we have copper oxide react with HCl. So what happens, that copper will combine with Cl. Copper, if it is 2 plus, because copper is a transition element, it can have variable state. So we take it 2 plus, and Cl is 1 negative. So the formula will be CuCl2 plus H2O. Copper oxide is a solid. Copper oxide should know that it is a black colored solid. Copper is a black solid. HCl is in aqueous state, copper chloride in the aqueous state, and water is in the liquid state. And copper chloride is a green solution. So you will get, when you put black colored copper oxide in HCl, you will see the color of solution will become green. Now let's balance this equation. You got 2Cl and you got 1Cl over here. So let's write 2 over here, and then it will be completely balanced. So let's see the next one. That is the reaction of, let's say you got zinc oxide and you put it in an acid like nitric acid. Now zinc will combine with nitrate, and zinc is 2 plus, nitrate is 1 negative. So we'll transfer this 2 over there. So the formula will be zinc bracket and it will be nitrate twice plus H2O. How to balance this equation? So let's write 2 here. Fine. We can have oxides, like we can have sodium oxide Na2O reacting with HCl. So it will give you sodium and chloride NaCl plus H2O. And let's try to balance this. Sodium is 2 here, write 2 here, and then we got 2 Cl's, write 2 here, and now it's balanced. So these are the reactions of the metal oxides with acids to produce salt and water. Metal oxides, I told you, they are the bases, and bases react with acids. This reaction in which acid and base react, we call it as a neutralization reaction. Neutralization, because acid and base, they are neutralizing each other and they are producing water. Now let's move ahead and see the next reaction. So number 3 reaction of acid is metal hydroxide plus acid. Metal hydroxide plus acid, they give you salt and water. Now let's write some equations. For example, we got sodium hydroxide. Remember, hydroxide is OH1 negative and sodium is Na1 plus. So the formula will be NaOH plus an acid like HCl, and they will react sodium and chloride. They will combine. Now sodium is 1 plus, Cl is 1 negative. So the formula of sodium chloride, it will be NaCl plus water. NaOH, aqueous, is a base, is soluble in water. HCl is aqueous, sodium chloride is aqueous, and water is in the liquid state. So let's see in detail what is happening in this reaction. We got a container. In this container we got let's say NaOH. So NaOH is in the aqueous state, so it will contain this solution. It will contain Na plus ions and Na plus and OH minus ions will be present in this container. Now we got another in which you have got like HCl. So HCl aqueous, it will contain H plus ions and Cl negative ions present in it. And when you mix them together, what happens over here? Now the Na and Cl, they will remain as it is in the solution because NaCl is a soluble salt, while H and OH, they will combine to give you water. So actually in this reaction, what is happening? The H plus ions plus OH negative ions, they are reacting to give you water. This reaction is known as the neutralization reaction because in this reaction, acid and base, they are neutralizing each other. So let's see some more examples. For example, you have calcium hydroxide and you put it in nitric acid. Nitric acid is HNO3. Now calcium will combine with nitrate. Calcium is 2 plus, nitrate is 1 negative. The formula will be Ca, and in the bracket you will write nitrate and write 2 here plus water. So calcium hydroxide in the aqueous state, nitric acid in the aqueous state, aqueous, and we got liquid over here. So let's see next reaction, that is like potassium hydroxide plus sulfuric acid. In this reaction, potassium will combine with sulfate. Now potassium is group 1, that means it is plus 1, sulfate is 2 minus. The formula will be K2SO4 along with water is produced. You got K2, so write 2 here and write 2 here to balance this reaction. Okay, one thing that I want to tell you, that this reaction that we have just written over here, this one, it is the reaction that is always taking place whenever you react with the metal hydroxide with an acid. And this reaction, which aqueous H plus, aqueous OH minus and liquid water is formed. This equation is known as the ionic equation of the reaction between an acid and a base. Let's see the next reaction. So the last reaction of acid is metal carbonate plus acid. So when you react a metal carbonate with acid, we get salt plus water plus carbon dioxide. So let's construct a reaction. Any carbonate you can have, like you can have calcium carbonate, CaCO3. CaCO3 is solid, it's marble, and if you react it with HCl, what will happen? Calcium will combine with Cl, and calcium is 2 plus, it will be, and Cl is 1 negative. So formula will be CaCl2. Along with we get water, H2O, and plus carbon dioxide gas is produced. HCl will be the aqueous state, calcium chloride is the soluble salt in the aqueous state, water is liquid, and carbon dioxide is a gas. So since in this reaction a gas is formed, we will see bubbles, we will see fizzing. So bubbles of the gas will be seen in this reaction. Let's balance, writing 2 here. Now let's move ahead. For example, we have sodium carbonate. Sodium carbonate is Na2CO3. Why it is Na2CO3? Because sodium is 1 plus and carbonate is CO3 2 negative. So that's why it will be Na2CO3 reacting with an acid like sulfuric acid, H2SO4. What will happen? Sodium will combine with sulfate. Sodium is 1 plus, sulfate is 2 minus. So it would be, sodium sulfate would be Na2SO4 plus H2O plus carbon dioxide. So we can have any carbonate, like we can have copper carbonate reacting with an acid like nitric acid. So copper is, let's say, 2 plus, nitrate is 1 negative. So we get copper nitrate CuNO3 twice plus H2O plus CO2. So balance this, writing 2 here. So we have seen 4 reactions of acids. The first one was metal plus acid to give salt and hydrogen. Second was metal oxide to give salt and water. Metal hydroxide to give salt and water, and metal carbonate gives you salt, water, and carbon dioxide. So these are all the 4 reactions of acids. Now let's move ahead and see the difference between the strong and the weak acid. Strong acids are those acids which are fully ionized in water. Now let's move ahead and see the difference between the strong and the weak acid. Strong acids are those acids which are fully ionized in water. For example, we got an acid like HCl. When you put in water, it will fully dissolve, fully convert into its ions to form H plus ions and Cl negative ions. All HCl molecules, they will break into the ions. No molecule will left unionized in this case. Similarly, You can have acid like HNO3. If you put in water, it will fully dissolve, fully convert into its ions, and 100% ionization takes place. All the molecules of nitric acid are converted into their ions. Similarly, we have sulfuric acid H2SO4. It will convert fully into its ions to form H plus ions plus SO4 2 minus ions. So these reactions, these equations represents that acids which are strong, they are fully ionized in water and no molecule left unionized. But what about weak acid? Weak acids, they are partially ionized in water. What do you mean by partially ionized? Means that they are not fully converted to their ions. For example, we have an acid like CH3COOH. This acid is ethanoic acid and it's found in vinegar. It is not fully ionized in water. When you put in water, it will partially ionize. That means all its molecules, they will not convert into their ions. Rather, some of them will convert to the ions while some will remain as it is. You can see this sign, reversible sign. It means the reaction is going on in the forward direction as well as in the backward direction. So, in the solution of ethanoic acid, ions and molecules, they are both present together and they are interconverting into each other. Organic acids, like the acids that we eat in our foods, like you got citric acid, tartaric acid, lactic acid, they are weak acids. In this lesson, we have seen acids, we have seen the reactions of acids, and we have seen the strong acids and the weak acids. And I hope that you have understood all this stuff. So right now, it's time to leave. Goodbye.